So these particular slides, as some information, are a little bit dense. I decided to maintain a lot of words in this slide. Usually I don't like slides with a lot of words, but so that you have it there. But essentially, I will touch some of these points, and some of them are there for you to eventually have some ways of going into more details. So we talked about middleware, so now let's see what is this middleware, at least some infrastructure of this middleware. Well, there is some basic middleware of all distributed systems, which you probably know very well because you have all taken some computer networks course. And this is the so-called TCP/IP protocol. And it is a middleware because it solves the problem of communicating among different systems. Different system meaning different system regarding the operating system, different system regarding applications which have some different, let's say, programming languages. And I'm not going into the detail of this one. There are some pillars and some, let's say, foundations. And these are the foundation, for instance, also in our case, of the web services, because we are developing services which will run eventually on the web, which runs over the internet. So at the bottom, you have standards for the internet protocol, so for the packages. You have a standard of communication, which comes in two flavors, the transport control protocol and the user datagram protocol. One is for implementing connection-oriented communication, TCP. The other one, UDP, is more loose kind of communication protocol, which is more unreliable, but it's more performant. So in some cases, it could be very useful. In particular, for instance, nowadays also very popular for peer-to-peer network distributed systems. And on top of this one, you have a number of communication channels, which are one possible communication channels. And the most, let's say, popular one are the one called sockets. And they are very low. Here we are really very low technical details, and we will not touch this level of details. We just need to know that all our application at the end, if they are going to use as a middleware for communicating among the various users, stakeholders, or actors, services, everything that you want to call them, are going to use the TCP/IP protocol. At the end, this is the infrastructure that they are going to use. We will start our, let's say, interest, our work will start on top of this system. And we'll start to talk as a first example of middleware, which dates back again in the 90s, beginning of the 90s, and which is called remote procedure calling, the remote procedure call in general. So is there some of you who are familiar with remote procedure call, who has been using remote procedure call explicitly during the university or outside the university? Good, in the sense that then you might be interested to know a little bit about it. But it's good also because it shows your age and it shows my age. Because when I started, we were programming in remote procedure calling, and now it has disappeared. And we will tell you a little bit about why it has disappeared. Essentially, it has not disappeared. It has just evolved in something different. So the basic idea about remote procedure calling is this kind of schema, which is very simple, and you know it very well. There's nothing new here. There is a program, typically which is called a service, that implements a number of potential services, and other programs like to invoke these services. There is a number of properties which makes these problems interesting. The client and the server typically are on different computers, are connected to a network. They only exchange communication with messages, and they have minimal guarantees about the error handling of these messages. This is the activity diagram, I think it's called, and it's very simple. The client, it's usually the one who starts the conversation or the operation. It sends the messages to the server. Obviously, it needs to know where the service is, and we will talk about that. And then the server, after a while, sends back a response. It sounds simple, and it sounds also very common. Why? Because it's fundamental to, is an idea that it's about 30-year-old, mid-30s, so a little bit more now. And it's at the basis of both remote procedure calling, RPC, and also a most famous one, which is HTTP protocol, because it is the real, let's say, communication pattern, request-response protocol that is used on the web. So the nice thing, the fact that RPC and HTTP are similar, and are similar also to more, let's say, modern way of building distributed system, distributed information system, is that they all have the same kind of problems. These problems are summarized essentially somehow in this slide. Maybe they are not, well, they are not in a particular order. We will start following this order here, but maybe it would be better to start. It's clear that one of the problems, if you have a situation similar to the one that we have here with this kind of exchange messages, first of all, you have to solve the problem that the client has to know who to call, okay? So you have, and this is up there, you have to know how to find the services. Once you find the services, you have to, I think there is a kind of, you have to invoke these services. So you have to have methods, approaches, methodologies, standards that allows you to call these services. Then you have to exchange data between the requester and the responser, so typically the client and the server. Various ways of doing this. In these 30 years, there has been a number of solutions for this one. And finally, there is something that it's always there in information system, which most of the times we forget about it, we leave it for the end, but you have to deal with the errors. So you have to deal with the fact that you need to provide what is called a good level or a certain kind of level of quality of service. So you have to think about all the possible ways that things can go wrong. And I would put here in the quality of service, nowadays has become even more and more, let's say, important, the question related to security, privacy, and things that are related to this. But it's not exactly quality of service, but is also in this part. So I will, in this lecture, I will go through just to tell you two of these problems, and I will kind of, particularly one, show you two different solutions to these particular problems that has been implemented in the past. And let's focus first on the service invocation. I mean, all these things, I mean, will be part of individual lectures later on in the course for the specific service-oriented architecture, but now I'm going to give you a more comprehensive view with some example. And one of the, so how to invoke, it's a question that it's related more or less to the programming languages and to the power of the developing environment that you are going to use. And the first attempt on this one has been simply to have a procedure inside your program that implements a function that can be used anywhere within the program. And the first implementation was called the remote procedure call. What is nice about the remote procedure call is that this kind of architecture is really at the basis, has remained almost unchanged in all the various, let's say, solutions. So it's also the same way as you will see in which you program the web, And it's the same way in which we will program web services. What's the idea behind it? It's relatively simple from the point of view of conceptual model. So you have a program in the client that has is developed in a programming language that allows the possibility to call something which is not in reality there on your machine. So it's called what is takes the name of a remote process, a remote procedure, not process, a remote procedure. What the model has is that in the client, it's possible to call, there must be something in the client which is real in order that to be able to make this call. And these things which is real is a stub procedure, which is only somehow an interface of this procedure. So it's not really the implementation of the procedure, because otherwise it would not be remote procedure, and it does it takes care of a number of important things that needs to be done. First of all, it has to bind with the place where this procedure is, so to the server on this side. So it has to know some information about the server. It has to deal with the data. That's the second point, but it has to do what is in this terminology takes the name of marshalling from the client side and unmarshalling on the other side the data. Marshalling means that you have to somehow transform your own data in some kind of intermediate format that can be sent over the communication channel and can be understood on the other side. And then it has to send, so it has to have some communication protocol, and in all our examples this sending will be done through the internet protocol, so the TCP/IP protocol, so through the internet. So it connects with a communication module which is internal to the client, otherwise the client will, otherwise this message will remains there, so it has to be a network kind of SCADA, a network card, and it travels. On the other hand, you have some kind, a similar but reverse kind of approach. But you can see it also from the colors and from the structure, which is very similar. The communication module takes the message. Usually there is a kind of a, let's say, daemon that decides, reads the messages and selects where to send it to the proper application. That's the thing that it's, let's say, for complex system, it's on this side, and it's on the server side and on the other side. And the server has a stub, that's the name of this kind of module, which does the reverse of the previous one. It takes the data, it tries to understand what is the message, so it does the unmarshalling of the data, so it brings it back, and this is interesting. If it is clearly, it is not necessary that the data representation in the client and in the server should be the same. You can have a machine which is a Java machine and the other which is a Windows machine, so the data representation is different. The only important thing is that here you have to have all the information in order to transform these data which are sent in the proper data that are able to understand on the server side. And then in the server you call the remote procedure. Is not everything is finished, because once you have called the procedure you have to do the loop back. So you have to go back through the server stub, which does the marshalling of the response, all the way back to the client stub, which does the unmarshalling of the response. And finally, the client receives, in that particular point of the code, which looks like a normal code to a normal local procedure, you will have your information back. So that's procedure, that that remote, let's say, call is the way in which you are able to, let's say, distribute or call services and procedure, in this case, which are on some other side. interesting things is that if I have to explain to you, let's say, how the HTTP protocol works or how the web services work, I would use a very similar diagram. So nothing has changed in these 30 years. So so there is no difference. In reality, there are some differences, but they are, as I said, evolutionary differences, mainly in the, I would say, the open standards. At the beginning, all these things were essentially wrapped together in particular, by particular vendors in particular packages or application, and you had to have the same, let's say, system on one hand, on the other. It was a good way of selling for big vendors like IBM and then later Microsoft, Sun, etc. So the open standards, the new protocols where are the protocols that are used now are essentially protocols which are language oriented, so they are verbose, as we will see. Here, one particular language will play a special role, has been starting to play in the last 10, 15 years a special role, which is the extended markup language, XML. And then we have to also acknowledge the fact that there is the rise of an infrastructure which has become very, very popular, which is the web, and which takes this, exactly this, let's say, approach and makes it standard so that everybody can use it. There is, before we go on, there is one key aspect which will be important, that's why I'm underlining in our course, that in order for making this kind of, let's say, things work automatically, what you need is a common way of describing the interface of this procedure or service. In this case, procedure and service are really the same kind of concept. And so in the remote procedure call, they started also for the first time to introduce the concept of a language that is used to describe the interfaces of these services in an abstract manner. Now, we don't really need to know all this. I really like to go directly to the diagram and to show you one example of a middleware RPC, which was called Distributed Computing Environment, DCE, Runtime Environment. If I'm not wrong, it was from IBM, and IBM has sold a number of these ones. And it looks, as you will see, as soon as we arrive at the web service, very similar to what we are going to use also now for our web services. So on the left, right, you have the implementation again of the communication that I showed you before with the client code, the client stub, on the other hand, the server stub and the server code. What you have in between and more and in the bottom, but now we will focus more on what you have in between, is that you have a repository somewhere, it's not in your machine or can be in your machine or can be accessible on the network, of a database of interfaces that are recognized and they are described in a particular language. In that case, it was called IDL, okay? Nowadays, we will call it WSDL, as you will see, Web Services Description Language, but the idea, the concept is the same. And it's this one that permits somehow this magic that your client is capable to construct automatically this tab, because all the things that are needed in order to create the client tab and the server tab are described in this language formally that essentially describes how you need to call each other. 1990, what happens also in around this period of time apart from historical music and things. But in the computer world, in the computer environment, what happens in 1989, beginning of 90s, the World Wide Web, okay? So this is not the World Wide Web. This is something that has been developed in the same time there. But at a certain point, so RPC was interesting. It was widely used in the enterprises for solving the problem of integration between different components. But it has some disadvantages. It was very low-level construct. It had only one type of interaction in mind, client-server, but I don't think this was really a very big problem because also the web was client-server. And this is the main point, that it was not a standard, it was not thought as an open standard, it was not thought for everybody to use, it was thought by a vendor to sell, to solve these problems and sell its products, okay? So another middleware arises, and if you think about it, if you have some knowledge of how the first kind of application on the web were doing, they were really remote procedure calls. And what was the difference between the first one? Well, the difference was that they were using one particular protocol, very simple one, HTTP, and not other fancy and proprietary protocol. They were exchanging, as I said, a common packages written in HTML. And at the beginning, the first real implementation in 1989, it was only with static pages. So it was only, the response was only a page that already existed. But right away, in the next 6 months, they started to put programs. And so there was essentially a transformation. It was possible not only to locate or to point to a page, but to point to a script. At the beginning, these were mainly called TGI script. And the script was run on the server side, was producing some results which were translated back to the user. There was a limitation also in this one, and that is that the answer back at the moment was only on an HTML file. So all the data has to be transformed into this format and sent back. So just one more layer. So everything that was available from, let's say, business and complicated business application. Here are the servers, but on top you had this middleware providing what was so-called transaction process monitor environment. Other, let's say, big software component typically sold to enterprises. And it was possible to use it on the web server. And people started to use it very effectively to do, first, things for personal use. And we know about that, e-commerce, and then nowadays even other things which are emerging very rapidly, like obviously the social web. But they started from the beginning to understand the power of the web in a business-to-business application, exactly to solve the problem of enterprise integration. And one of the big success of the web, one of the many, was also a way of essentially, by wrapping the individual middlewares and services under a standard web server, standard protocol, a standard language, it was possible through the internet to be able to integrate and to merge various applications. So the problem of, one could say, the problem of application integration was, enterprise application integration was solved by the web. Yes and no, okay, it was a good one part of the solution, but there was some limitation. Good, so that we have more work to do as engineers, and we can invent some new architectures, and we can invent some new features. What are the limitations of the web? The design, the initial design of HTTP was really designed for something which is completely different from business-to-business integration, even to e-commerce, social media, and things like that. It was originally, as you know, it was done as a document exchange protocol. So it's so we are really pushing to the extreme this kind of protocol. And we continue to do that because it's a very stable and simple protocol. But on top of this, on top and below, there is a lot of things that we can add to make a new application. The document format was designed to cope with, so what is HTML is essentially a way in which you tell a program, which is a browser, how to show a document. And then you have some features adding links and other things. But it is essentially more a syntax and not a semantic. So it does not give you information about what is the content. It does not give you information on how to deal with the content. In particular, it does not give the information to machine to how to deal with this concept. So it needs to be extended, and it has been extended, as you know, with XML. And again, the HTML is really more about text and not about function. So this slide is just to say that there is a number of things that in the current middleware infrastructure of the web can be improved. And this is the road of, let me just advance you on this one, of service-oriented architectures. Now, I'm not going to talk about the other problems because we are going to have lectures on how on service-oriented architectures these problems of exchanging data between machines is solved, okay? And we will talk also a little bit about, not here then, on how to find the services, which is another interesting, let's say, topic. Also because this one, there is a lot of space at the moment. Obviously, it is solved for the web, right? Now, how do we find the web, our website? Search engine. Okay, so the solution of this problem, let me tell you, for the web has really, let's say, had a lot of economical impact. How can you call it? Okay. So to find a solution for this particular problem for the web had the possibility that many, let's say, players, in particular one, as you know, has made a big market. So if similar things at the moment, let's say, exists on the services. Unfortunately, the scale is different. So the need to find website or to find information on the web is much stronger than the need to find services at the moment. But who knows, maybe this is a place where to play a little bit. And the other one is about coping with errors. Now, that's more or less, I keep on staying a little bit repeating on this slide, because this is more or less a slide which somehow brings together the problems that are also there for web services. And as usual, a lot of solutions or techniques of patterns that have been developed to solve these problems in other systems are going to be used or has been used in the web services. And so we close with an initial, let's say, presentation of what is called the, let's say, basic at the moment, service-oriented architecture. And the basic service-oriented architecture sees at least three, let's say, actors. You will need to start from one. So let's start from the provider, for instance. So let's say that you want to write a service and provide a service to someone. Could be internal services in one enterprise, in one institution, in one company, or it could be a completely public service that everybody can use. So what you have to do is in this kind of architecture, you have to do two things. First of all, you have to have the implementation of the service, and then you have to provide a description of the service, which takes names also of a contract of a service. And you can keep it yourself. You can put it in some repository. If it is an internal service, the people will know where to find it. If it is not, it would be nice that you publish this one in a public space so that the people on the other side, which are the service consumer, will be able to find it. So once a number of service providers are there and a number of services are published, then the service consumer can start to search for it, either by knowing it. There is a strong analogy really with this kind of architecture that with the web. At the beginning, when the World Wide Web started, the way to know about possible sites was really using, friends or someone who was telling you and typing you, look and go to this site with the address of the site. And this is similar to the situation now. At the moment, there are a number of libraries, there are a number of repositories, but they are not yet a search engine for services. So somehow the service consumer is able to find that there is a service which potentially is of interest. And then what he needs is to find the service contract, which is the description of the interface, download the service contract and construct automatically, semi-automatically, with human supervision, without human supervision. Depends really on the kind of support, software support that you have. But you are able to create the client tab and then to start the communication. How it is implemented? It is implemented with a number of standards that you might have heard. And these are the ones that we will present in this course. SOAP for the exchanges of the messages. So in place of using HTML, we are exchanging messages in a particular format, and we will have lectures on this format, SOAP. The service contract that we are talking about is going to be written in a language. It is an interface description language, not only that it's an open standard. It's written in XML. We will go also in some details of that one. We'll see how it is constructed and why it's very, let's say, popular. And it's called WSDL, WSDL. And then there is also a proposed standards for the discovery part. We will maybe mention, we will have maybe lectures on that one, but we are not going to use it because it's not widely used. It's not very successful at the moment. So as a matter of fact, the web services that are based on this kind of technologies usually are called SOAP services, because the most important let's say, characteristic of this service is the use of this protocol, and I have to say also the WSDL, the combination. Only that SOAP WSDL web services is a little bit complicated, long, so usually it's contracted with SOAP. But this is the overall characteristic. And how do they map with this list of problems? Well, WSDL is the one that deals with the service invocation. SOAP is the one which deals with simple object access protocol, with data exchange. It's called Simple Object Access Protocol. UDDI is an attempt, which stands for Universal Description, Discovery, and Integration. And as the name wants to do too much, and it kind of failed a little bit. Wants to deal with finding the services, and this generic to deal with errors and also other things like security and privacy. It's what is called typically WS star extension. So you want to deal with quality control, you have WS quality protocol, or WS transaction, or WS secure transaction, etc., etc. So you deal with a specific application. But these are the basics, and these other ones are somehow, let's say, extra. And there is a commonalities of all these approaches, and the commonalities is that all are based on XML. So all are based on extensible markup language. That's why we will start from the next lectures with this particular, with the lectures both here in front-end lecture and in particular in the laboratory from Tuesday with XML. So if you know XML, fine, you will be already practiced a little bit about that. But we need to start with it because we cannot really give it for granted because it is at the foundation of all the others applications. So we will spend the time that is needed, depending also on your background and on your. We will do a check next in the laboratory on what you know and how you deal with it. And if it is already something that you know very well, we will move a little bit farther, or we will have to speed on that one. So to finalize, what is SOA? In a few words, if I have to say in a few words, which are not here, here is a lot of words, is the first one, is a way of standardized the evolution, the development, the engineering of a particular type of, let's say, remote calls. And it is about services, it is about architecture. It has a couple of properties. Well, the first property is common with the web. It is message-based, so you want to detach as much as possible the implementation of the service to its actual use in the client. And that is also because it's called an architecture which is loosely coupled. I mean, obviously there is some coupling. Coupling means there needs to be some interaction, so the service cannot be completely detached by the clients. There must be a way in which you can attach this one, but this kind of interaction has to be very loose, has to be very limited. You need not to know everything about the details of the service in order to use the service. You have to need only enough, just enough information. Standardization effort is the most important, and one would say, well, standardized, it's easy, I do one standard, I follow this standard, and I have it done. Unfortunately, it doesn't go this way. And what is out there at the moment, and it is also, I mean, a demonstration of the fact that this environment, this field is still not mature. There are a number of protocols, a number of standards. They have a lot of things in common. First of all, they are XML based, so it's fine, but there are really a big number of them. And it depending on your application, and in this picture, there is the typical picture of the manager in a company or in a project that says we need to integrate our application using web service technologies. And the poor programmer or whatever the system engineer who is there has to deal with a large variety of possibilities. So one of the things of this course we hope is that we will go through, not all of them, I promise, only few of them, but just to give you an idea of what is out there. This is a picture which together with the previous one is the one with the words is the list of problems, and this one is the list of technologies is a typical service-oriented stack. It starts, I put it there because just to remind you that we will travel on top of existing protocols for transport, but we will not touch them. We will not go any information about HTTP or TCP. We just use them. Here is where we start really with XML. XML, as is shown in this stack, is really the foundation of all the various standards. And then there are some functionalities. The messaging part, so how we transport messages. And here, typically, The most important one is, as a protocol, is SOAP. We will learn what it is and how to use it. And, but there are also some more other ones, addressing, notification, eventing, some specific one for specific application. The other important block is the description. And here again, there is a protocol that plays a very important role, which is WSDL. And then we will go through it a little bit. There is a number of protocols that can be grouped together depending on the type of functionalities that you need. So if you want to have security, then in place of having one protocol of messaging which includes security, the choice has been to divide these ones. So the standard messages does not have security. If you want security, you can add on top something else which provides you with security. It is somehow the same things that has been also the line of thought and implementation of the web. If you don't need security, it's HTTP. If you need security, it's HTTPS. And so you move it there. And the same things for reliability. If you really need to know that your messages have arrived because they are critical information, you are in a hospital, so it's not that just you send information and this information can be lost. You really need to know that it has been arrived, when, etc., etc. Then you add reliability. In banks, typically in financial application, you add transaction, and that's our field. On top of this field is a stack of a layer of protocols that allows you to combine your services into a process automatically. Tell you that we will not go at this point. This is part of another course which is called Business Process Management, because that is where essentially you start to need these kind of protocols and standards. So I stop here. It's, as I said at the beginning, an overview of the whole course. I hope now it's clearer. If there are some questions, comments, you're welcome. Is the speed of the lectures fine? Speed in terms of talking, essentially, because we are from different countries. I mean, English is not our native, not mine, not yours, and it's maybe in some cases it's yours. So just tell me, give me feedback if I should slow down, or even if I can speed up, it's fine. I cannot speed up too much, but okay, thank you. So next lecture is a laboratory lecture. Read the website to know where it is, because we don't have yet the final room, okay? And so read there will be on the bulletin board also downstairs, but if you go to the website, you know it even before. Thank you.